Did you know that the Hatfield rail crash in 2000, which resulted in tragic consequences, was caused by a type of rail defect called rolling contact fatigue, RCF? The crash claimed the lives of 4 passengers and over 70 were injured. Rail defects are a real risk that need to be managed. Join me through this video to look at some of the most common types. Before we delve into rail defects, let's have a quick look at what rails are made of. Rails are typically made of steel and come in various profiles. They provide a smooth surface for train wheels to run on. However, rails can experience failures due to a variety of factors. Now let's discuss some common types of rail failures. Wear. One common type of rail defect is called wear. Rail wear occurs when the steel material gradually erodes over time due to the repeated contact between it and train wheels. This can lead to the railhead becoming worn down and uneven, affecting the stability and safety of the track. As well as the head of the rail, the area most susceptible to wear is known as the gauge corner. This is known as side wear. This is particularly an issue on curves and is caused by the profile of the wheel flanges. As well as the obvious issue that the rail is being worn away, wear causes issues for maintenance teams trying to install new rails. Where the rails are very worn, getting the head to line up with that of the new rail to give a smooth running surface becomes difficult. Welding moulds have been developed to allow welding between old and new rails, but only up to a certain level. For jointed track, lift plates are used. These lift the old rail to avoid a step. Rolling contact fatigue, or RCF, is another defect caused by the passage of train wheels across the rail. Train wheels actually make contact with the rail in a very small area. The area is around the size of a pound or euro coin. This leads to high stress in the rail in a very localised area. This can cause small cracks to form and then grow in the surface of the rail. They appear as S-shapes. If not removed, normally by grinding or re-railing, the crack can grow and then they link up. It can lead to the catastrophic failure of the rail. As we said earlier, this caused the fatal rail crash at Hatfield in 2000. Areas of RCF are graded based on the severity from light to heavy and finally severe. Welding into heavy or severe RCF is discouraged, as the intense heat can cause the cracks to worsen quickly. This can lead to issues with finding suitable areas to cut in when changing rails in RCF areas. Both wear and RCF are influenced by local conditions such as track curve radius, levels of can, train traffic type and speed. Lubrication can be added to the track to mitigate the risks. Corrugation. Continuing with surface defects caused by the passage of trains, next we have corrugation. Visually, this looks like a wave or rippling on the surface of the railhead. Normally found in areas of heavy acceleration or braking, such as on the approach to a signal, it can be caused again by the train wheels. Think of a car struggling for grip with wheel spin. It has a similar effect. The repetitive, local deformation of the railhead can lead to other issues, particularly noise and track geometry issues. Plastic flow or lipping. As we've already touched on, the action of a steel wheel passing over another steel surface can cause defects. As well as the crack, etc. we have talked about, it can also lead to what is known as plastic flow. This is when the high stress of the wheel contact area pushes material away, like a paste. In material science, plastic means permanent, so the metal doesn't go back to its original location. Over time, this leads to metal flowing to the edge of the railhead, where it lips over. Known as lipping, this has a number of issues associated with it. Firstly, lipping can tear off, causing damage to the railhead. This is a big issue in cast crossings, where both sides of the railhead may see traffic, compared to a standard rail, where lipping on the outside is less of an issue. The other area where lipping can cause issues is within switches. Lipping of the stock rail can cause the switch rail to fail to properly close, leaving a risk of the switch being forced open and the wrong route taken. Our last external defect is corrosion. We need to remember that rails are steel that are laid out in all weathers and conditions without, for the most part, any paint or coating. Corrosion can affect any part of the rail, but it's most pronounced in 2 areas and for different reasons. Let's start at the top, with the crown or head of the rail. This area right on top of the rail is important, not just because it's the area that the wheel runs on, but also for track circuit signalling systems. It is where the current is passed between the rail and the wheel. This completes the circuit that shows the signallers and signalling system that there is a train in that area of track. Pretty important stuff. But on areas of track that are rarely used or are in wet environments such as tunnels, the head of the rail can corrode or rust over. This layer between the rail and the wheel can stop the electrical current passing, stopping the train appearing on the signalling system. This is incredibly dangerous, as it could end up with a train-on-train collision. It's a similar to effect of what happens with leaves on the line. Check out a video on this for more. While corrosion of the head of the rail rarely leads to the failure of the rail, corrosion of the foot is a more serious risk to the integrity of the rail. The foot of the rail is particularly susceptible to corrosion as it often sits in areas that are wet, dirty with contaminants such as road salt and grit, like tunnels, under overbridges or in level crossing. These areas speed up the rate of corrosion compared to that open area where water drains away. Level crossings are a particular area of risk due to road gritting and salting in the winter months. Because of this, the level crossing decks are lifted to allow the rail foot to be inspected. On main road level crossings, rails with special coatings can be installed to help increase resistance to corrosion. Before we move on to our next type of defect, if you're enjoying this video and want to know more about railway engineering, a perfect place to start is my free PDF guide to Cant. Cant is a fundamental part of railway track geometry. My PDF guide gives you all you need to know, and the best part, it's completely free. Hit the link in the description below to get your free guide. So now let's look inside the rail. There are a number of different types of internal rail defect. First up, squats. Squats are probably the most common type. They bridge the gap between surface and internal defects. They are easy to spot due to the localized depression in the rail and a dark spot. They look similar to bruising on an apple. They are an issue because of the micro cracks that can propagate and lead to a rail break. Squats can be caused in a number of ways, ranging from wheel spins and track geometry issues such as voiding, to ballast and other debris on the head of the rail being crushed by passing train wheels. Depending on their size, they can be repaired with either arc welding or a head repair alumothermic weld, or by changing the rail. The second most type of internal defect is a Tache Ovale, or TO. The name comes from the French for oval spot, which describes their appearance. Unlike our other types of defects in this video, Tache Ovales are inherent within the rail from excess hydrogen within the metal. This is a manufacturing defect. It grows as the rail is in the track and subject to load. It is also only possible to be detected by ultrasonic inspection, after which the rail needs to be changed to remove it. So there we have the common type of rail defects that maintenance teams need to detect and remove to ensure the safe travel of trains. I hope you've enjoyed this video, and if you have, do give it a like, drop a comment below with any questions, and give the channel a subscribe. Thank you.